Computer science made easy. Computer science made easy.
Hey everyone, and welcome! So, have you ever just looked at the world of programming and felt completely overwhelmed? I mean, you've got Python, Java, C++, JavaScript, the list just goes on and on. Well, today, we're going to crack the code. We're diving into a framework inspired by a really great blog post from Professor Mukesh Tekwani that pulls back the curtain on just four fundamental concepts that are like the secret DNA inside pretty much every single programming language out there.
And I'm not exaggerating. Seriously, think about it. Just like all the spoken languages in the world, there are literally thousands of programming languages, each one built for a slightly different job. It's this huge, sprawling landscape, kind of like a modern-day Tower of Babel. And you think to yourself, how could I ever master all of this?
But what if that's the wrong way to look at it? What if I told you that underneath all those different keywords, all that weird punctuation, that nearly every single one of these languages is built on the exact same foundation? A kind of universal genetic code for telling computers what to do.
That's the secret. 4. Despite all that crazy complexity you see on the surface, it really all boils down to just 4 fundamental concepts, 4 core ideas. And here's the cool part. If you can really, truly get these 4 things, you'll have the key to unlock the logic behind any programming language you ever come across. All right, let's jump in with concept number 1, data structures. Now, the absolute easiest way to think about these is as the nouns of programming, right? They're the things, the stuff, the actual information that our programs are going to work with. So, the key word here is organization. A data structure isn't just a random pile of info. It's data with a system. It's all about storing that information, whether it's a username, a high score in a game, whatever, in a way that makes it super easy and efficient to find and use later on.
And the most common, the most basic kind of data structure you're going to see everywhere is a variable. A variable is really just a named container, a placeholder for a piece of information that might change over time. It's kind of like having a cup. The cup is the container, but what you put inside, coffee, water, tea, that can be different every time.
So, what kind of stuff do we actually put in these containers? Well, these are the most common data types you'll find. You've got strings, which are basically just text. Then you have integers for whole numbers, 1, 2, 10, 100. Floats are for numbers of decimal points. And booleans, which are actually super simple. They can only ever be true or false. That's it, a simple yes or no.
Okay, so we've got our nouns, our data. Now we need some verbs to actually make them do something. And that brings us to concept number 2, control structures. These are the actions, the decisions, the logic that really brings all that data to life.
And what's really crucial to get here is that code doesn't just run blindly from top to bottom. No way. Control structures act kind of like a traffic cop for your program, directing the flow of what happens next. They let your program react to different situations and make choices as it runs.
And it mostly come in 2 main flavors. First, you've got looping. This is all about repetition, just doing something over and over and over again until some condition is met. Lather, rinse, repeat. Then you have branching, which is basically a fork in the road. It uses if-then logic to choose the path. If the password is correct, then let the user in. Simple as that. Okay, so we've got our nouns, which is data, and our verbs, our control structures. Concept 3, sequencing, is like the grammar that puts it all together in an order that actually makes sense. It's all about the rules, the recipe, the step-by-step order of operations. And at the very heart of sequencing is something called an algorithm. An algorithm is nothing more than a recipe, a list of really precise steps that you have to follow in the exact right order to get the result you want. If you change the order when you're baking a cake, you don't get a cake, right? You get a big mess. It's the same in programming.
And to write that recipe correctly, you've got to follow the specific rules of the language you're using. And that's where syntax comes in. Just think of syntax as the spelling and punctuation rules. It's like how a misplaced comma can totally change the meaning of a sentence in English. While in programming, a syntax error, like a missing semicolon, will just stop the computer dead in its tracks. It won't have a clue what you're trying to say.
So we have our nouns, our verbs, and our grammar. But what happens when our programs get really, really big and complicated? Well, that brings us to our final and maybe the most powerful concept of all, abstraction. This is all about taming that complexity by learning to focus on the big picture.
And I absolutely love this quote from MIT's John V. Guttag because it just nails it. Abstraction is the art of strategic forgetting. You focus only on what you need to know for the task at hand, and you hide everything else away.
I mean, think about driving a car. You don't need to understand the physics of internal combustion or how the transmission works. You just turn the key, press the gas pedal, and go. The car's interface has hidden all of that insane complexity from you. That is abstraction.
Here's another great way to look at it. Baking a cake from scratch means you have to deal with a dozen different ingredients and steps. A box mix, on the other hand, abstracts all of that away. It hides the complexity of measuring flour and sugar and baking soda, so you can just focus on the important parts, adding the eggs and oil, and get to the good part faster.
So, okay, we've gone through all 4 concepts, but why does any of this actually matter? Well, it's because learning to program isn't really about learning a specific language, it's about learning what you can build with the language.
I really love this analogy. Think about it. Just memorizing a dictionary isn't going to make you a great writer, is it? The real skill is knowing how to combine those words into sentences and those sentences into paragraphs and eventually build a whole compelling essay. The programming language, it's just your dictionary.
And this is the real journey of becoming a programmer. You start with syntax, the words, but that's just step 1. The real skill comes from using logic to form sentences, then designing bigger components that are like paragraphs, and finally, having that high-level architectural vision to construct the entire application, your whole essay.
And that's really the big takeaway here. When you focus on data structures, control structures, sequencing, and abstraction, you're learning the universal art of solving problems with a computer. You're learning how to write the essay. And once you can do that, you can pick up any dictionary, any programming language, and start expressing your ideas.
So that's our take on the 4 universal pillars of programming. But, this is a huge topic, and we'd love to hear what you think. Are there other fundamental ideas that you believe are truly universal across all languages? Did we miss a 5th concept? A 6th?
I'm genuinely curious to hear your perspective. So drop your ideas, your arguments, anything you think we might have missed right there in the comment section below. Let's get a real discussion going on this. And finally, if you got something out of this breakdown, it would be awesome if you'd subscribe to Computer Science Made Easy and maybe share this explainer with anyone you know who's just starting out on their coding journey. Thanks so much for watching, and keep on building.